Intro to polar coordinates. A polar coordinate system uses distance and angles to record the position of points. A polar coordinate system. You're used to working within an XY coordinate system, a two-dimensional XY coordinate system. Another name for an XY coordinate system is called rectangular coordinate system. Rectangular. I don't know why they picked the name rectangular, but they did. But the traditional coordinate plane that you work with is also known as the rectangular coordinate system. Now, in a rectangular coordinate system, you had an X and a Y. Well, you do not have that in a polar coordinate system. In a polar coordinate system, you have an R and a theta. That's your ordered pair, R and a theta. And we're going to talk about the relationship between this and this later on. But today we're just getting used to R and theta. R refers to distance in terms of rings from the center. The rings, because you notice there's rings in here. And theta is the angle at which you're moving out from the origin. However, in the polar coordinate system, a fixed point is called the pole. We call the origin the pole. This center right here is the pole. In a rectangular coordinate system, you have a horizontal axis that's known as the x-axis and the vertical known as the y-axis. Where in the polar coordinate system, you only have a polar axis. From here to here is the axis. That's the foundation. And from there, you move around it at a different angle. So here's your axis. Now, you're going to often hear me call, say, the vertical and horizontal, but just know that that's not the x and y, okay? The only axis you have is this polar axis, which is the base, and from there you move at whatever angle around the system. Does that make sense? Okay. The polar axis is usually a horizontal ray directed from the right of the origin. We just talked about that. The locational point P in the polar coordinate system can be identified by the polar coordinate. We already talked about that. R and theta. And you need to know that R and theta is very important. We've already discussed that. Okay, I'm just going to get to the point here because all that's not going to make sense. We're just going to start graphing a point. It says plot the following coordinates on the polar graph. You're going to love this. I do like this. And like I said, after Christmas, this is math that you've never ever seen before. Okay. Okay. I want to plot the point 245. What I always tell students to do first is find your angle. Okay. You say, Mr. I don't see 45. Well, you might need to fill in the chart a little bit. Let's do this. Let's do this. What is pi over 6 equal to? 30. This is how much right here? 60. This is 90. This is 120. This is 150. This is 180. 210. 240. 270. 300. 330. And you're back at 360 if you need that. Guys, only work with the ones we did. We didn't have one that we didn't work. That's pi over on 12, but we didn't work with that. So we're just going to start with pi over 6 and go from there. We're just going to work with stuff that we've been working with. Okay. Now, what's the one in between the pi over 3 and pi over 6? 45. Let's go back and fill that in. Okay. 45, 90, 135, 180, 225, 270, 315. And since the 45 did not have the pi over 4, I'm going to go back and put that pi over 4. This is 3 pi over 4, 5 pi over 4, 7 pi over 4. Just so I can have all that information. Okay, so the first thing you do, guys, is you find the angle, 45. 45 is right here, isn't it? start at your pole. You're going to go, that R is distance, but I refer to it as the ring number. If I'm right here and it's 45 and it's got a 2, I'm going to go out to ring 2. Move that paper a little bit. Like here, I'm here, there's 45, I'm going to go out to ring 2, and that is my point, point P. Point Q, locate your angle first, 270's down here. What ring do I want to come out to? So I start at the pole and go down 1, 2, 3, 4. That's point Q. Point R, 180's at pi. I want ring 3, so I'm going to go toward 180, ring 3. Point S, 50, 0 degrees is right here. I'm going to go out to ring 5. 1, 2, 3, 4, 5. That is point S. Point T, 2, 3 pi over 4. I'm going to find the angle first. 3 pi over 4 is right here. I'm going to go to my pole. I'm going to come out to ring 2. And that is my answer. So take a moment. That's not too bad, is it? Kind of neat. No, okay. The notes is on your desk, but Oski, how are we coming over? Okay. Now on the Lamson's policy, you might need to focus on number and see the back. All right, now let's look at point U here. We have negative pi over 3. Negative pi over 3. That's why locate your angle first. Normally pi over 3 is up here, but negative pi over 3 is going to be down here in quad 4 as the pi over 3 family member isn't. Okay? So I'm going to find that. So I'm really at 5 pi over 3 now. I'm going to go to my pole, come out to third ring. 1, 2, 3. And that is point U. Now this is where I need you to pay very careful attention at. Angles being negative, you've been dealing with negative angles all year, but we're about to deal with a negative R. And this, where there's going to be something different here. Alright, find your angle first. This is 0. Traditionally, I would have went 5 to the right towards 0, wouldn't I? What does the negative symbol in math mean sometimes? Opposite. So instead of going towards 0, where do you think I'm going to go toward? 180. If there's a negative R, you go in the opposite direction. So I'm natural. I'm going 1, 2, 3, 4, 5. That is point D. That's how you handle a negative R. Always find your angle first and then deal with your R, okay? Is everybody good so far? Alright, point W. Negative 135. Normally 135 is over here at the pi over 4 mark in quad 2. But since it's negative, it's going to be the pi over 4 family member in what quadrant? Quadrant 3. Okay, quadrant 3. So I'm going to go to the pole. I'm going to come out to the second ring. 1, 2. See, Mr. Fisher, why didn't you do what we just did? That R was not negative. R was not negative. So that's point W. Alright, point X. Negative 2, 150. Jake, who sits next to you? Okay. Negative 2, 150. Find the 150 first, right here. 5 pi over 6, 150. Okay, I normally would have went out to the second ring, but since it's negative, what quadrant do you think that's going to be in? It's in 2, so I'm going to go to 4. From 2, it goes across to 4. So I find the pi over 6 family member in quad 4, and I go out to the second ring. And that is X. Alright, we're going to do a couple more. Do we need to do all 6 of these left? Okay. Let's look at point Y. Negative 7 pi over 6. Okay. Regular 7 pi over 6 is in quad 3, isn't it? But we want to go negative, so we're going this way. 1, 2, 3. So we're in quad 2 at the pi over 6 family member. Okay, if it had been traditional, just 3, I would have went out a third ring. But since it's negative 3, I'm going to be actually in quad what? 4. I'm going to go across to the pi over 6 family member and go out to the third ring. Take a minute to make sure you understand that. Are there any questions on how I got point Y? Alright, let's look at point Z. Find y pi over 2 is here, come out from the pole or the origin. Same name. Okay, normally I would have went up 2, but since it's negative 2, I'm actually going toward 3 pi over 2. And that is point Z. So our first learning target was I can graph polar coordinates. Do you understand that learning target? I need a hand signal to the chest.
You do C and D.
C and D?
Yeah.
Okay. Alright, let's look at C. Negative 3 pi over 4. Normally 3 pi over 4 is in quad 2. But since it's negative, it's going to be in quad what? 3. Quad 3. But then let's look. Negative 4. If it had been 4, I went out in ring 4. But since it's negative 4, I'm actually going to be in quad what? 1. So I'm going to go to pi over 4. Oh, I need to go one more, sorry. So that's a big no-no right there. Quad 4 is point C. Point D. 7 pi over 4 is normally in quad 4, but since it's negative, it's going to be in quad 1. And the R is positive, so I'll just go out to 4. It's going to be in the same spot.
Are A, B, C, and D on the same?
Yes. Yes.
So when you have a negative angle, you just do it like a normal unit circle.
Mhm.
You just go back.
Yeah. One point's like 3 points on there, yes. If that was confusing you. A, B, and C, yes. All same points. And what? O and D. I hadn't never worked. Yeah, gotcha. Alright, now, that was our first learning target. Now, our second learning target is what? Is that Mama texting you?
No, I'm on phone.
Yes, she was, but
But not.
if I say it again, it's mine. Alright, Zach, will you read our learning target, please? Put it face down on your desk, not on your lap. Huh?
Second one,
Mm-hmm.
I can convert polar coordinates to rectangular coordinates.
Alright, so what we're going to do next, guys, is we're going to start going back between, we're going to take a polar coordinate and convert it to a rectangular. And when I mean rectangular, I mean an X and a what?
Y.
And then we're going to take an X and Y and convert it to a polar. We're going to do all that today. Alright. So, on number 1, it says convert the following from polar to rectangular. So I'm going from polar to rectangular. Alright. This time I need you to, don't try to memorize something. I just want you to think about it. If I'm going from polar to rectangular, I need a what? X and a what? Y. Okay. So I need an X equals and a Y equals. So here's the formula. Ready? X equals R times some trig function. What trig function do you think what's associated with X? Cosine. There's your formula. X equals the ring times the cosine of the angle, and Y is equal to R times the sine of the angle, okay? So that's what you do on all 3 of these. So let's look at number 1. So I want an X and I want a Y. So X equals 2 times the cosine of 3 pi over 2. What's cosine of 3 pi over 2? 5, 4.
Square 3 over 2?
Cut. What is the cosine of 3 pi over 2? I'm going to ask you one more time. Thank you. Or I'm going to pop a 20-question trivia quiz on you in 2 minutes. So you do that again, we will go there. Okay. X equals 2 times 0 is 0. Okay. Y equals 2 times the sine of 3 pi over 2. What's sine of 3 pi over 2? And that gives me negative 2. So my ordered pair here would be 0, negative 2. And let's think about this, guys. If you were to graph this on the polar coordinate plane, wouldn't that be directly south? Would that be 3 pi over 2? 3 pi over 2 is here, 2 down, wouldn't it? If you were to graph this on the traditional coordinate plane, wouldn't that be the same kind of position? That's how they're related. Okay. Yes, Fossey, you have a question?
No, I'm stressing.
You sure? Okay. Let's look at number 2. This is in polar, and I know that because you said degrees here. That's your ring. So let's do x equals negative 3 cosine of 120, and y equals negative 3 sine of 120. 120, what's your reference angle there? 60. Very good. 60 degrees, pi over 3. So cosine of that would be negative 1/2, because it's in quad 2. So your ordered pair here would be negative 3/2 and negative 3 square root of 3 over 2. You can leave it like that. It would be, thank you. And let's think about this. If you were looking at this, if we were to graph this, 120 is in quad 2, isn't it? But since it's negative 3, it would be in quad what? 4. Wouldn't it go across to quad 4? Does that make sense? Quad 4. If you were to graph your answer here, your x is positive, your y is negative. Isn't that in quad 4? Okay. Do I need to do the third one? Or are you good on those two? We're good? Daniel, you good? Okay. Alright, the next thing we'll do is convert from rectangular to polar. Rectangular to polar. And how do you know these are rectangular? I don't see any degrees. Okay, so if you're going to rectangular to polar, what 2 things do you need to know? R and theta, don't you? Okay, so let's write the formulas for R and theta. R equals square root of x squared plus y squared. Haven't we seen that formula a lot? And then to find your theta, use the tangent formula, and we're going to talk about that in a minute. So those 4 formulas you need to memorize, because you're going to use them throughout the unit. Alright, so number 4, we want to convert it from rectangular to polar. First thing I'm going to do is find my R. R equals negative 1 squared plus square root of 3 squared. That gives me 1. The square root and square cancel out, gives me 3. R equals square root of 4, which equals 2. You can go on with that. That'd be good.
I'm trying to get it.
Just don't let the peppermint fall on the floor. Now, let's find the angle. Tangent of theta equals y divided by x. What's y divided by x in this situation? Negative square root of 3, isn't it? Because square root of 3 divided by negative 1 is negative square root of 3. So now you've got to think back. Which reference angle deals with a tangent of square root of 3? Pi over 3 or pi over 6? Pi over 3, isn't it? Yeah, pi over 3. Now, if it's going to be a negative, where's that family member going to come out of quad what? 2 and 4. What pi over 3 members are in quad 2? 2 pi over 3. And which one's in the fourth one? 5 pi over 3, isn't it? So you got to make a determination which one of these are you going to use. I'm going to teach you which one, how you know. So you got two choices always at this point, two choices. Now, go back to your original problem. Original. What quadrant? Okay, so I got -1. It's going to be either quad 2 or quad 3, isn't it? Your y is positive though. What quadrant are we working in? 2. So which one of these is in quad 2? That's the one you choose. So your polar point is 2, 2 pi over 3. Because this is in the same quadrant as the original problem. Just got a question before we start working. -2 to 0. -2 to 0 will be over here with what angles over here? What angles over here?
180.
So you would what? What's the radius of 180? Pi. You see how that's related? We're going to see that in a minute, but you can go and picture that in your mind. That's going to be pi. Alright, so let's find our r. R equals -2 squared plus 0 squared. R equals 2 because the square root of 4 is 2. Tangent of theta equals 0 divided by -2. Tangent of theta equals 0. Which ones give you 0? That's at 0 or pi. And because this is sitting in the same spot as pi would be, your ordered pair is 2 pi. I'm not going to work number 7 in a minute, but we can look at that. What will be your R value there? What will be your R value? You're all intelligent. Number 7. We'll skip the 6 for a minute. Will be 5. 0, 5 will be north with it. Which angle is north? Pi over 2. So that'd be 5 comma pi over 2. Does that make sense? Yes.
I still don't understand how you
How I got number 4?
Yeah.
Okay, do you understand how I got these angles right here?
Yeah.
Okay, if you're looking at the coordinate plane, -1 square root of 3, if I was to plot that on the standard coordinate plane, -1 up some number, square root of 3, that's in quad what?
2.
Which of these are in quad 2? 2 pi.
Okay.
Let's look at number 6, our last example, and I'll let you work on your homework. You have 15 minutes to do your homework. Number 6, I'm going to adjust it a little bit. Alright, on number 6 here, we're going to find our R. -square root of 3 squared plus -1 squared. A negative squared would be positive, and the square root cancels out, so I'm left with 3 plus 1, because -1 squared is 1. So R equals square root of 4, which is 2. Tangent of theta equals y divided by x, where a negative divided by negative is a positive. What's wrong with this right here? There's a radical in the denominator. Possible, it's in your lap. Is your phone in your lap? Okay, never mind. What do you need to put in front of it? Alright, the radical right there causes problems. You got to rationalize. So that comes out to be what? Square root of 3 over what? What reference angle does that deal with? Pi over 6 or pi over 3? Okay, it's going to be positive, so it's going to come out of what quadrants? Quadrant 1 or quadrant 3? So you got pi over 6 and 7 pi over 6 are your choices. Now, how do we make the final choice, TJ? What quadrant would the initial one be in? 3. So which one of these are in the third one? So your order pair is 2, 7 pi over 6. That wasn't too bad, was it? tomorrow we're going to start converting equations. This is just coordinates today. Okay. Instead of doing 1 through 11, I'd like you to do 1 through 17 for that now, because you got 15 minutes. 10 minutes. You can get a lot done. 1 through 17.